Yeah. Okay, so let's get going. Starting to record. So Premier Products is a business. It has customers and it sells things. So let's have a look at that. I'm trying to. Yeah. First, we got a couple of definitions here. We got this definition of a database. Database is where we store data, but it's a little bit more detailed than that. It's a structure containing categories. Categories is a strange word. The word that would be you could interchange it with the word entities. Those are things about which we store data. And so here's some examples of some entities or categories. We could have the category or entity of sales reps, of customers, orders, and parts. And this is kind of typical for a business, and that's why we're using this example. Now, so we would store all of the things that we want to store about sales reps in a sales rep category or entity, or you'll see that that translates to a table in SQL. Likewise for customers, orders, and parts. Now, there may be some relationships between the entities or the categories. That is, for example, a customer has a sales rep. And so the customer only deals with one sales rep. Now, sales reps may deal with many customers, but each customer only deals with one sales rep. Every order is going to be an order for a customer and an order of some parts. So there's a relationship between the orders entity or the orders category and the parts and the customers entities. And this is very important that we understand that for how we design our database and how we use it with SQL. As we need to understand these relationships because we build the relationships into the database. All right, so a little bit more about the example that we're using. So this company, Premier Products, sells some stuff that people buy, houseware, sporting goods, etc. They used to use a manual system. That's amazing. Yeah, I suppose, is there anybody using a manual system? I don't know, but anyways, now they want to use something that's computerized, and so it says so they've designed this database management system. The categories, which I've referred to as entities as well, they roughly translate to tables. So each of these categories will have a table which will store the data for them. And so just going through each one of those categories or tables, the sales rep data, this is the data that you store for every sales rep. The number is going to be a unique identifier. That means that for that particular number, it only applies to one person, that one sales rep. You could have two sales rep with the same name, but they would have different numbers, and that's how we would identify them. You'd be familiar with this because these kind of unique identifying numbers are used all over the place. For example, you have your student number here at the college, just in case two students have the same name. We refer to them by their student number, your cutter ID number, your license number, etc. Unique identifiers. Customer has a number like that, and there's some other details about the customer. Isn't this interesting? There's a little bit of data that is stored in the customer entity or table, which is the sales rep which has been assigned to that customer. So each customer is assigned to one sales rep. Each sales rep may have many customers. How that is achieved in the database is that we use a field in the table, and we call it a foreign key. And so the sales rep number is used to produce the relationship between the two tables or between the two entities. Okay, so the parts table, again, it's going to have a unique identifier, which is your part number, and then it stores a lot of other stuff about the parts. And some of that stuff is kind of updated regularly, like how many which warehouse those parts are found on, how many of those parts are on hand at any particular time. So every time you sell a part, you'd have to update the parts table to remove one from the inventory. The price of the part is also stored there. So what you're looking at now, I would call that an invoice, or they call it an order invoice. And if you look at that carefully and look at all of the information that is there, you'd realize that that comes from there's no one no one entity or table of the things that we've looked at that contains all that information. So, for example, the customer details that had to come from the customer table. The details of the sales rep had to come from the sales rep table. The details of the parts that had to come from the parts table, and the order details, which is the order number and the date. That had to, and the customer number, I think that had to come from the orders table. So the this is a report. This is an example of a report. So this report was made up by gathering data which is related from from the uh, from the different categories or tables that make up this database, and that's what we do in SQL. And you'll see us doing a lot more of that um, a little bit today, and as we go on with this topic. I hope this looks familiar to you. This is a table structure. This is how we conceptualize the data. I was going to say that's how we store it in the computer, but actually the computer is going to store it as a bunch of zeros and ones, isn't it? But this is how we conceptualize how it's stored in the computer. You see there that we've got a representative number, which is unique identifier for the sales rep, and the other information. We've talked about that in the previous slide. And so there's what is found in a particular for a particular sales rep. Now, each one of these rows in the table, we refer to that as a record. So we've got our fields. Each column we would call a field, and each row we would call a record. And altogether, we'd call that that's our sales rep table. There's information about a sales rep. This is our customer table, unique identifier for the customer. When I say unique identifier, you'll see that there's only one record allowed in the entire table that has the number 148 as the customer number. There's other things can be repeated, but the unique identifier cannot. All right. So we can only have one record in the entire table, which has the number 608 for the customer number in the customer table. 608 can appear a lot of times in other tables, but in this table, no, because it's the unique identifier. On the other hand, we have an identifier over here on the rightmost column. Um, I'm speaking slow. Am I? I didn't think I
Your voice was lagging before. That's
Uh,
why.
that that'd be the communications between here and there. Um, all right. Oh, lost my train of thought. Where were we? Yes, the representative number on the right side is quite different because you'll see that there are repeats there. The 20 recurs more than once, and so does the 65, and so does the 35. So these are not unique in this table. They're unique in the representative table, but not in the customer table. This is called a foreign key because we use that to draw the relationship between the two tables. This over here, the customer number, that is the primary key. Okay. And I'm just thinking about that. Yes, it does lag. Probably as I'm talking, you can't see the cursor moving. Oh, that'd be kind of sad. Zoom. No, it's not Zoom. It's the computer, the network in between here and there. I'm pretty sure. Anyway, so there's some more on a customer record. This is an individual record from the customer, and we've talked about that. Here's our part table. Unique identifier for the part is the part number, and we've got a bunch of other stuff there which is stored. Some of that stuff is not going to change very much, like description and class and price probably won't change too much, but you would find that the on hand, the number on hand would have to be updated regularly. Um, every time you sold one or bought one, you'd have to update it. Um, Right, so that's the part table, and there's an example of a record. And here is the order table. The order table is really quite orders table. Sorry, orders table. It's quite important table. I call it a transactional table. It's a transactional table. It's because this is where a transaction is recorded, and transaction is going to tie in other tables. So what we notice is that the fields in this table, or at least one of the fields, is a key for another table. So a order number, every order must have a customer. And so we can get all the details of the customer from the customer table if we know which customer we're talking about and we know them by their unique identifier, their key field. And every order must be on a particular date, and we have our order number. Um, and so there's some example of an order there. Now we've got this other table, and what's this? All right, so this is order line table, but we already had the orders table. So what's this orders line table? And this is because you can have a situation where in a single order, which is made by a customer, they're ordering more than one part. And this causes us a problem. How do we store in the database the fact that a particular order, same order number, but more than one part? And we're going to look at a couple of ways of doing that. And there's only one really right way. There's so because we think sort of conceptually different than a computer might, we might come up with a solution which looks good to us, but wouldn't work for the computer. And we'll talk about that in a minute. But what we need to do is we talk about one-to-one relationships and one-to-many relationships. So, for example, there's a one-to-one relationship between the what uh, in this table for a particular order, the part uh, in that order, uh, yeah, will only occur once in that order. That's right, because we can have multiples of it, but you won't have multiple lines with that in that order. So that's a one-to-one relationship. On the other hand, uh, that was a bad example to use because in a particular order you could have more than one row with the same part. Now, how do I know that? Because look at this order: 608. No, 610. 610. We have the part number. More than one part is associated with the same order. So that's a one-to-many relationship, and one-to-many relationships require you stripping things out into multiple tables. Okay, here's the alternative. What if we tried to have multiple parts in the same order? Then how do we relate, this or this one back to this customer number, back to this order date, etc. That's why we have to separate them out. This would be a bad table design. We should never do this. We should, instead of having one orders table, which includes all of this information, we separate out the part numbers into another table in the order line table. And so that's what we've done. Yeah. So, as it says there, the alternative order table is not a good way to go, and we shouldn't do that. So the order line table, when we separate things out, whenever if we find ourselves with many to one relationships inside the table, we should take that out and make another table. Now, I just realized what I'm talking about. I'm talking about relational database design. Now, you guys don't need to do relational database design for this course. So if you are going to do the software strand, you're going to do relational database design later. Don't worry about it now. I'm not going to ask you to design a database. Okay, so there we go. That's all you need to know about them, I think. What we need to do now is we need to look at this exercise that you're going to be doing, and hopefully you can see that. Let's make it a bit bigger. So here's our tables. All the data is there before us. You can download this from D2L. I put the links to it for today's work. Okay, so there's all the data. And then what you have to do today, you do not need to touch a computer to do this. Well, except for you're going to type in the answer and submit this, right? Well, okay, so it's a Word document. So, but you do not need to touch a relational database. What you have to do is you have to look at the question, list the names of all the customers that have a credit limit of 7,500 or less. You have to look at the question and then look at the tables, figure out which table or table, because I haven't showed you how to do relationships yet. Figure out which table is going to give you the information. So it talks about customer there, right? All the names of all the customers that have a credit limit of 7,500 or less. And so that would be in the customer table. And look at that, there is a field there. There's which is credit limit. So looking at the customer table, how would we get the names? So if we look in the table, we can see that there's a field called customer name. We want the names of all the people that have less than 7,500. Well, you could just scan down here, right? Look for a number less than 7,500. Oh, there we go. There's 5,000. So the name there is the Everything Shop. And going down, there's another one with 5,000. And the name there is Lee's Sports and Appliance. So I would then go here and write their names, and that's all you have to do. Okay, now if you wanted to get really keen, you could write the SQL query if you think you know it, but you don't need to. Do not need to write the query. The Everything Shop is one of them. It has a credit limit of only 5,000, and the other one that was Lee's Sporting or something. Not Lee's Sporting, yeah. Yeah, anyways. So they have that. So that's all you have to do. And I want you to do that for the rest of them. Maybe we'll look at one more. List the order numbers for orders placed by customer number 608 on that day, the 23rd of October. So you want the order numbers. So you look at our orders table. Here's our customer number. We're looking for 608. And then we see if it's the right date. Yes, it is. So there's two of them that are on that day. And so the order numbers would be this number, 21617 and 21623. And so that's how we'd answer that. So 21617 and 21623. Now imagine, I mean, you got a database and you're going to go and look in the tables and see if you can see the answer. What's the point of having it on a computer, right? The computer allows you to do this automatically and quickly when you write the right query. If you're interested, I'll just show you the queries, how we do this. This is what SQL looks like. So for the answer of this one, the customers, we would say select, and we would say customer name because that's the name of the field. So this is the way we do an SQL query. Select field name from, then we say the name of the table. Customer, is it customer or customers? It's just customer. And then we have the condition, which we put a where clause, where credit limit is less than 7,500. And that is how we would write it. That would return for us. That would give us this result. Now, in the next one, similar, we would say select. You don't need to do this. I'm just showing you. This is what was going to happen in the near future. Select what? Select order number from orders. So we say the field name that we want from the table that we want, then the condition where, what was it? Customer number equal 608. Now customer number won't actually be a number. It's going to be text because you don't do math on it. And because there's more than one condition, we have to separate it with an and then we would say order date equal, and hopefully the date is stored in that format. The problem with the date is it's a special kind of field in SQL, and depending on how you have set up your database, it might be in this format or it might be in another format. Anyways, that's how that works. And you don't need to write the SQL commands. If you think you know how to do it, that's awesome. Go ahead. All you have to do is do the answers. So one last one. List the part number, part description, and on-hand value for each item of class SG. Okay, so I'm not going to write the answer, but we'll just look at it here. Okay, so part number, part description, on-hand. That's going to come from the parts table. So we would look at the part table, not parts table. So we want the on-hand. What do they want? They want the description. We want that too. Part description, part number, and on-hand value. On-hand value is a calculated value. Okay, so we have to calculate the on-hand value. It's not actually stored in the table. We have to calculate it ourselves. You can do that in SQL. You can say this field multiplied by that field, or this field multiplied by some number, or divided by, or whatever. You can do calculations. So what we're going to have to do to get the value is we find, if you look in the field that's called on hand, we can see, for example, in this one here, 9, you could multiply that by that price, and that would give you your on hand value. Now, SQL will do the calculation for you. You you don't need to write the SQL query for this. We've already gone through all of that. But let's just see if I use my calculator. Let's see, 9 times 1390 is 12,510. So what we would say is, okay, they wanted the on-hand value for everything which is in a class SG. So this one here, the on-hand value is 12,515, 510, sorry. And then the other one, which is a SG, there's only one other, is this one here. And so that's going to be 45 multiplied by 794.95. 794.95 times 45, was it? Yeah. 35,772 and dollars and 75 cents. So that's how you do it. I shouldn't do any more or you won't have any work to do. So I'll leave you the rest of it with you. And I'm going to stop talking now and I'm going to stop recording, I think. So let me see if I can find, where's that? All right, there we go. Uh, pause share. No, I don't want to pause share. I want to stop.